We believe autonomous driving is the future, and it will bring us a lot of advantages. Compared to today's traditional system, it's safer and will reduce roadway deaths. It also improves transportation efficiencies, provides more comfort, and has a positive environmental impact. Hi, I'm Daniel Bogdanoff, a test geek here at Keysight, and thanks for joining us. Today we're excited to unveil some new technology and hear from some automotive industry leaders, key stakeholders, and the engineers behind this tech. While the possibilities of autonomous vehicles are exciting, there are some immediate challenges automakers must overcome to make it a reality. Think about all of the decisions we make while driving a car and how long it took to become a good driver. I think some of us are still getting there, but that's the challenge. For autonomous driving to be reality, we need to build complex systems that are better than the best human drivers. Even for today's advanced driver assistance systems, known as ADAS or Level 2 or 3 autonomy, there are hundreds of different sensors that need to work together and software algorithms that need to take in all the data and make the best possible vehicle decisions. At the end of the day, you must have extreme confidence in your ADAS and autonomous vehicle functions. So how is this functionality tested today? Early in the development cycle, designers use software simulation tools. This allows you to simulate the underlying sensors, vehicle dynamics, and even performance in varying weather conditions. When paired with 3D driving scenarios, this works pretty well, but it's difficult or even impossible to fully emulate a real-world system response. So you can physically take the vehicle to a test track or in some cases public roads. However, ADAS and AV in modern vehicles is so complex, a thorough system test would require driving billions of test miles. This is obviously not a practical approach. It would be inefficient, expensive, and potentially dangerous. Software simulation and real-world road tests will never go away because the end goal is to have roadworthy vehicles, but today's technology isn't what it needs to be. We need a change. We need to make repeatable tests in real-world conditions with real sensors before going out on a test track. We need to bridge the gap between software simulation and the real world. One critical area developers focus on is radar. We need a better way to emulate radar targets. Today, we're going to unveil some exciting developments we've made in this area, a technology that offers a completely new way to train your ADAS and AV algorithms and provides full scene emulation so you can exercise your radar sensors. It speeds up ADAS testing and provides real-world performance validation in multiple scenarios, from bustling city traffic to quiet country roads, and even tests those 1 in a million situations. The road ahead for autonomous vehicles is exciting, and the momentum is building for developers to cross that proverbial chasm from level 2 or 2 plus towards the goal of wider availability of levels 3 and 4 and ultimately level 5 autonomous driving. Before we go into more detail, let's get some perspective from Bill Visnick, editorial director from the industry standards organization SAE International, and learn more about what it will take to help automotive OEMs move towards full vehicle autonomy.
Creating safe and robust automated driving systems for future vehicles is a complex task. Engineers in this space face immense challenges, not the least being the testing processes typically used in algorithm development for ADAS and AV applications. No technology currently exists to allow developers to create the almost infinite array of driving simulation scenarios, including difficult-to-define edge cases that would be encountered in the real world. Extensive road testing is a vital component, of course, but road testing brings its own challenges, including time and cost. Another problem with road testing is the uncontrolled environment, a particular issue for training ADAS and AV algorithms. As the automotive industry expands deployment of automated driving technologies, early algorithm training in the lab can ideally help make these challenges more manageable. And in-lab testing has to cover much more than simple object detection. It must also fully emulate all the driving environments and allow for repeatable testing under the same conditions, while simultaneously increasing test coverage. This comprehensive level of in-lab testing is critical to ensuring, for both OEMs and consumers, that new ADAS and AV systems function as intended and ultimately make the right decisions on the road.
Like Bill said, we need to emulate a full environment in lab. Getting to level 5 full driving automation requires representation of total roadway scenes. Without this emulation, we simply can't trust these decision-making algorithms with our lives. The industry's vision is to fully replace the human behind the wheel and let the vehicle make reliable, accurate, and safe decisions on the road under any circumstance. We're excited to unveil Keysight's new autonomous drive emulation platform, which will help make this vision a reality. Here's a short clip that explores the challenges developers face and more about the autonomous drive emulation platform.
Forecasts are optimistic for the growth of the autonomous vehicle market. Those forecasts depend on the confidence in the minds of consumers, regulators, and the insurance industry. Confidence in the safety of advanced driver assistance systems is built on detailed testing, but it can take hundreds of millions of miles of road testing, actual or simulated, to explore corner cases and qualify new designs. Autonomous operation depends on high-resolution radar and camera systems working in concert with incoming navigation data. Business goals for size, weight, and cost are driving the sensor fusion of discrete elements into compact but complex subsystems. A typical testing process involves a vehicle on a test track. Whenever the vehicle approaches a physical target, the sensor system can be tested. This open-loop, single-unit method is slow, labor-intensive, costly, and insufficient. The complementary approach is time-synchronized testing of complete sensor subsystems, using detailed simulations and a closed-loop approach. This method exercises sensors, electronic control units, and AI algorithms as an integrated unit. Working in collaboration, Keysight Technologies, IPG Automotive, and Nordsys have created an innovative solution called the Autonomous Drive Emulator, or ADE platform. Here's how it works. Each subsystem is mounted in an ADE simulator rig. The real-time 3D engine creates a virtual environment that includes full-motion video, dynamic radar signals, and congested C-V2X scenarios, 4G today, and 5G NR in the near future. The unit under test responds with actions such as braking, steering, and acceleration, just as it would on the road. This expedites testing through cumulative hours of simulation and the measurement of feedback from every element of the ADAS system. With state-of-the-art realism, the ADE platform enables developers to confidently test their designs and then focus on the debugging and fine-tuning of system behavior. Because the ADE platform is open, it simplifies integration with a wide range of commercial 3D modelers, hardware-in-the-loop systems, and existing test and simulation environments. With AVs, market growth depends on confidence, and confidence comes from highly realistic testing. The ADE platform is ready to streamline the test pipeline. This is just one of the ways Keysight is helping OEMs and their suppliers realize their vision of mobility.
Keysight's Autonomous Drive Emulation Platform, or ADE, is an environment emulator for in-lab testing using realistic roadway scenarios, from the mundane to the 1 in a million. Using total scene generation, the platform exercises ADAS software using time-synchronized inputs to the actual sensors. It provides total scene generation. This required breakthrough technology for the emulation of radar signals beyond the limitation of today's radar target simulator technology known as RTS. Developing this technology was a job for our applied research laboratory, Keysight Labs. We set out to develop a system with a minimum of 20 targets and a plan to increase that number in the future, the ability to emulate complex RF-dense urban scenes, and the ability to generate static and dynamic targets with varying ranges and velocities. After getting over 24 patents, the new radar scene emulation technology developed by Keysight Labs is the heart of the ADE platform. This is revolutionary technology that helps close the gap between software simulation and roadway testing. To give you a peek behind the scenes, let's hear from some of the R&D folks at Keysight Labs that made this technology a reality.
Hello, and welcome to Keysight in Böblingen. My name is Henrik Liebau, and I'm the R&D manager responsible for the activities for Keysight's Autonomous Drive Emulation platform. As Dan mentioned, to realize road testing in the lab, the core gap was the exercising of the radar sensors, as current technology is limited. So let's start by doing a quick review of what's available today for in-lab testing. A radar target simulator, or echo generator, will come in two flavors, analog or a digital version. Both methods receive and transmit, simulating distance, radar cross-section, and velocity. They both are complex and expensive instruments and can emulate a limited number of objects from a single direction. Although modern RF engineering and the shrinking of component sizes has facilitated a smaller front end for radar target simulators, making azimuth and elevation testing possible, today's test systems use multiple RTSs, each presenting point targets to radar sensors and emulating horizontal and vertical position by mechanically moving the antennas around. In a static or quasi-static environment, this enables tests with a handful of targets moving laterally at speeds that are limited by the robotic arms. While this is an improvement, it is still limited in its coverage of realistic use cases. The list of corner cases from mundane to 1 in a million that should be tested keeps growing, and the RTSs of today are limited to a few targets and mechanical movement rates. We needed a way to solve this problem so that these scenarios can be tested even in a lab environment. Now let's hear from Kazim at Keysight Labs on Keysight's new solution that shifts from the emulation of objects to the emulation of full environment scenes.
Thanks, Hendrik. Hi, everyone. I'm Kuzem Unchwaniwala, R&D Program Manager at Keysight Labs, responsible for some revolutionary new technologies being developed here to enable test and emulation solutions for communications, computing, aerospace and defense, and automotive applications. Building up on what Hendrik just said and going one level deeper, let me take you to the heart of the ADE platform, towards the technology that shifts from target detection to traffic scene emulation. Now, here are the key design considerations for our solution. Scale to the customer's real-world traffic scenario needs while avoiding mechanical motion. Keysight's new technology accomplishes this by reducing even further the size of the remote heads and densely packing them into a very small space. To make this happen, there are two major breakthroughs. First, the highly integrated modulator device, designed in an ultra-high bandwidth HPT process with in-package transmit and receive antennas, allowing for the miniaturization of the remote head to roughly 30 by 10 millimeters, enabling the creation of a radar pixel. We leverage Keysight's state-of-the-art 3.5 semiconductor fab with MMIC design expertise to achieve this compact form factor. Second, using Keysight's over-the-air millimeter wave expertise and the innovative radar pixels, which are then arranged in an array and packed tightly into an anechoic chamber, creating a radar screen less than 1 meter from the dot. This pixelated wall is invisible to the radar sensor and is only activated as a target when the scene generator software programs it to do so. Several key innovations have enabled us to avoid the sensor from seeing the pixelated radar wall, hence preventing false targets in our emulation chamber. It is an amazing piece of technology and innovation, and we are very proud to see it all come together to address the gap in the current ability to render complex scenes. Think of the endless possibilities in traffic scene emulation this technology enables. Our team has been hard at work collaborating with our early adopters on the testing of these ADAS and AV use cases. Several of them. A pedestrian runs over a narrow street, or a bike swerves into the lane coming from nowhere. Urban traffic, more than 5 targets, 2 cars at intersection, oncoming car, passing car, surprised pedestrian, cross traffic in a busy intersection, cars going fast through the intersection. You can see how these complex traffic scenarios require a revolutionary new solution to emulate. And that is what the radar scene emulator technology will realize. I'll hand this demo back now to Hendrik, who will walk us through some of the additional components necessary to utilize this new technology.
Thank you, Kazim. So exciting to see it come together. Remember, radar sensors are just one type of sensors that we want to exercise. So let's zoom back out and look holistically at the testing environment. Wireless sensors provide information that is not in the line of sight and can be very important when applied to the decision-making of your AV and ADAS algorithms. All your vehicle's line of sight sensors, like radar, camera, or LiDAR, and the wireless sensors, cellular or Wi-Fi based, and geolocation, of course, need to be time synchronized so that the ADAS AV system has a complete and accurate picture. In fact, some of the more dangerous traffic scenarios involve objects which are not visible in the classic sense, being behind hills or around the corner, and testing in the lab would be preferred due to safety considerations and cost involving in test of the road. As such, it is necessary that tests run in the lab in a closed loop environment because decision of the driving algorithms immediately affect the behavior of the simulated vehicle. It starts with the 3D modeling software that creates the scene. Data for the sensors in the system are rendered, time synchronized, and then sent to the respective hardware. which exercises them. The output of these sensors then ultimately tests the decisions of the ADAS AV algorithms by monitoring the behavior of the vehicle through a closed-loop hill system. The software translates accurately rendered 3D models into the associated sensor stimuli, overcoming latency and synchronizing the testing of ECUs, software, and the real sensors. Rendering for radar sensors is done using off-the-shelf gaming-level graphics card using ray tracing, just like in a computer game. The realistic image needs to be synchronized in time with the inputs to the other sensors to provide a consistent image of the world to the decision algorithms. Keysight software will ensure this for various simulator and modeling tools. So let's put it all together. Radar scene emulator, wireless non-line of sight sensors, and the time synchronization software. With this, we're very excited to bring you highly realistic testing into your lab, exercising all types of sensors with very detailed scenes, very close to the real roadway scenarios. So thanks for joining us today, virtually, behind the doors of Keysight Labs. And I'd like to introduce Dan Thomason, our head of Keysight Labs, to you to share a few words.
Thanks, Henrik. Hi, everyone. I'm Dan Thomason, Vice President of Keysight Labs. Well, for over half a century, our job in Keysight Labs is to invent and deliver the breakthrough technology that enables Keysight to offer our customers world-leading solutions for design, test, and emulation. Keysight Labs has hundreds of scientists and engineers around the world, and they apply their expertise to advance the state-of-the-art in applications ranging from communications to quantum computing to autonomous vehicles with electric drivetrains. For example, Keysight Labs was central to delivering the most innovative 5G test solutions to the wireless industry. This is now enabling mobile network operators and others to bring their products to market faster and at lower cost. By working across the industry, from research groups and standards bodies to chipset and handset makers to service providers and others, we enabled 5G so it can connect people and things like never before. To make such things possible, Labs has built deep expertise in antennas, millimeter wave, optics, signal processing, advanced software algorithms. We even operate our own advanced semiconductor fab here in California. These are ideally suited to inventing breakthroughs for developers of autonomous vehicles. And we've assembled a powerhouse team of Keysight Labs innovators who are doing just that. Because to give automotive leaders confidence in their autonomous systems, a drive emulation platform needs complex scene emulation. And the current solutions out there with a few horn antennas on robotic arms emulating point targets, those just don't do it. Those don't emulate a real-world environment. You need the ability to emulate that child crossing the street with parked car, street signs, pedestrians, the whole scene. That's why we invented the Keysight Radar Scene Emulator technology, to act like millimeter wave VR goggles for your sensors, to enable you to emulate complex and realistic traffic scenes. The entire Keysight Labs team shares tremendous excitement and commitment to autonomous drive emulation because it's not just an opportunity to invent breakthroughs to delight our customers. It's also motivating, it's inspiring to be part of realizing the vision of autonomous transportation, to make it more efficient, more enjoyable, and to make it safer. We share a passion, and we are committed to giving our automotive customers the breakthrough tools you need to truly bring the road into your lab.
Thanks, Daniel and team. We at Keysight believe that the automotive industry is very important, and as you can see, we are investing heavily into these technologies, and this is not the end. For more on that, here's Wei Xin, president of Keysight's Electronic Industrial Solutions Group.
Thanks, Daniel. It's great to be with all of you here today. As president of Keysight's Electronic Industrial Solutions Group, I'm privileged to see firsthand the incredible changes going on in the electronics industry around the world. In the automotive space, OEMs are racing toward goals of zero accidents, zero emissions, and zero congestion. These are complex problems, and it demands innovative solutions in all aspects of automotive design and test. Keysight is proud to be a driver of innovation in the automotive space. Last year, we announced our collaboration with industry partners, Northeast and IPG Automotive. Together, we have designed and developed a modular test platform to accelerate validation of advanced driver assistance systems and functions for autonomous driving. With our technology demonstration today, we are taking a big step forward in realizing that platform and taking aim at a critical challenge in the autonomous vehicle market, radar sensor testing. These advancements is enabling a paradigm shift to total scene generation across the entire field of view of a modern radar sensor, and we are just getting started. We are proud to share this amazing technology achievement with you today to demonstrate our continued commitment to enabling the ongoing transformation of the automotive industry and to helping OEMs realize full vehicle autonomy.
Thank you, Wei-Sin. We hope you enjoyed today's event and thank you for your time. We at Keysight are excited to bring the road to the lab with our new ADE platform. Make sure to stay tuned for more innovations from Keysight. Until then, if you want more information on this technology, please fill out the survey on the console at the bottom of your screen. We'd love to partner with you. Thanks again for your time.